mTOR is one of the cell's master decision makers. Every moment, cells receive information about nutrient availability, energy status, oxygen levels, stress, and growth signals such as insulin. mTOR integrates these inputs and determines whether conditions are favourable for growth or whether resources should be conserved. When nutrients and energy are abundant, mTOR activates programs that promote protein synthesis, lipid production, cell growth, and proliferation. It tells the cell that this is a time to build, construct proteins, expand membranes, store fuel, and divide. Through pathways linked to insulin, PI3K and AKT signaling, mTOR helps coordinate metabolism with growth demands. In tissues such as liver, muscle, and adipose tissue, excessive activation can contribute to insulin resistance, fatty liver disease, obesity, cardiovascular disease, and cancer. But mTOR also has an opposite side. During fasting, stress, or low energy states, mTOR activity decreases. This allows cells to enter maintenance mode, activating processes such as autophagy, the recycling system that clears damaged proteins and organelles. In this state, the emphasis shifts from growth to repair and survival. Because of this balance, mTOR is increasingly viewed as a central regulator of aging, metabolism, and chronic disease. Too little signaling can impair growth and healing, while persistent overactivation may drive uncontrolled proliferation and metabolic dysfunction. In essence, mTOR functions as a cellular gatekeeper, continuously deciding whether the environment supports expansion or demands conservation.